Well, good morning, everyone. This is day 3. We are starting chapter 3, so we'll begin with 3.2. Okay, so let's begin. Some things that you've done before in Algebra 1, so this should be familiar to many of you. So let's say here I was solving this equation, 2x plus 6 equals 4. So we would know, so I have 2x plus 6 equals 4. So we know enough to solve for x. We need to isolate x. So the first thing we would do, recall, we would subtract 6 from both sides. And then let's see here, so we would have 2x equals negative 2. And then we would divide by 2. We divide both sides by 2. And we would get x is equal to negative 1. So it may not have occurred to you that when we actually solve or solve for x for that equation, 2x plus 6 equals 4, what we're really doing is finding the intersection of two linear equations. Okay, so if you recall from Algebra 1, a linear equation is of the form y equals the slope times x plus b. We're actually solving for two linear equations. Okay, in this case here, the first linear equation is just the equation y is equal to 4. In other words, my slope is 0 and my y-intercept b is 4. So to recall, the y-intercept is where the line crosses the y-axis. So the equation y equals 4, that's just a horizontal line at y is equal to 4. So I'll draw that in. So y equals 4. And then the other equation is y equals 2x plus 6. So that's my other equation. All right, so to recall, that has a y-intercept of 6. So I'll start at y is equal to 6. That's my y-intercept. And my slope of 2 tells me to go up 2 and over 1. Go up 2 and over 1. Or likewise, I can go down 2 and run left. So 1, 2, 1, 2. Okay, and then I can draw that line. It's a linear equation. And right there at the intersection of the two, right there at the intersection is the two, I get x is equal to negative 1. But that's the same thing I got when I solved for x there. So again, when I solved for 2x plus 6 equals 4, what I was really doing was finding the intersection of two linear equations. The first one, y is equal to 4. The second one, y is equal to 2x plus 6. I was finding the intersection of two linear equations. And that's what we're going to be doing today. We're going to be solving a system of equations, of linear equations. Okay, so I'll write the formal notation for that, and we use this curly bracket. And so the equations that we were actually solving for was y equals 4, and then y equals 2x plus 6. Okay, so that curly bracket, it really means this. It means this. Find the x that makes the y's equal. Find the x that makes the y equal. Okay, so that's what that curly bracket means. Find the x that makes the y equal. Well, we did that, okay, when we solved for x there. All right, as you can see in this picture here, for both equations, the y's are equal. The y's are equal. All right, so let's begin today's lesson here, but keep in mind, that's what we're really doing. We're finding the intersection of two linear equations. Now, the first method we're going to use is called substitution, solving a system of equations using substitution. Okay, so here the graph shows a system of linear equations. As you can see, without the use of technology, determining the solution from the graph is not easy, okay? And I guess what they're saying is this here. Those two lines, they really don't cross at the grid lines. It looks like the intersection here is something like, I don't know, little x is less than 1. It looks to be like x is 0.8 or so. And y happens to be like 1.2. And that's just a guess, all right? Okay, but we can use substitution to find an exact solution rather than guessing. In substitution, you solve one equation for one variable and then substitute this expression into the other equation. So to go back to what I had the equation y is equal to 4. Y equals 4. And then y is equal to 2x. This is the simplest and yet most important substitution we'll ever have. Okay, where y is equal to one thing and y is equal to something else. It's the simplest and yet it's also one of the most important. Okay, we have a system of equation. Find the y, x that makes the y's equal. Okay, I'll show you why it's so simple. So here's the thing. If y equals a and y equals b, then we can say that a equals b. I mean, that much is obvious. If y equals a and y equals b, then we can say a is equal to b. So to solve this system of equation, y equals 4 and y is equal to 2x plus 6, all we have to do is substitute what y is into the other equation. Okay, so here y is equal to 4. Y is equal to 4. So I'll substitute what y is into the other equation. I'll substitute it for that y. And so then I'll just write 4 is equal to 2x plus 6. And as we saw before, then x is equal to negative 1. I solved that before. X is equal to negative 1. Now, if I go to test my solution, let's see here. I'll substitute x for negative 1 there, and let's see here what we get. We get y equals 2 times negative 1 plus 6. So that will give me y is equal to 4. Okay, so there. So that's substitution. In substitution, you solve one equation for one variable and then substitute this expression into the other equation. All right, so let's continue on. Here's an example. Solving linear systems by substitution. Use substitution to solve the system of equations. So step 1, you solve one equation for one variable. Okay, the first equation is already solved for. I have solved for a variable. Y is solved for. Okay, it's isolated. It's by itself. Then you substitute the expression x minus 1, which is y, into the other equation. You substitute it for that y. Okay, so we had x plus y is equal to 7. Then we substitute what y is, which is x minus 1. We combine our like terms. X plus x is 2x, so we have 2x minus 1. Then we add 1, we get 8, and divide by 2, we get 4. Okay. So substitute the value of x. So we solve it and we got x is equal to 4. That much we know so far. We're still not done. Remember, in solving a system of equations, we want to find the x that makes the y's equal. Okay, so we found what x was that makes the y's equal, but we still don't know what y is. Okay, so what we do, we take what we found, x is equal to 4, and then we substitute it into the equation that had the variable solved for. Y equals x minus 1. Okay, so it's always easy after you solve for the first variable, substitute it into the equation where the other variable was solved for. Y was already solved for. It wasn't solved for. It was solved for y. So y is equal to x minus 1. So we're going to substitute 4 in that equation. And then what we get, so we get x is equal to 4, so we get y equals, so x is 4 minus 1, and that equals 3, so y equals 3. So our solution to this system of equations here is the coordinate point x is equal to 4 and y is equal to 3. And what we should do, we should always check, okay? Okay, so we should take these values here and substitute them into the original system of equations to see if we get a true statement. Okay, so let's do that with this equation, number 1. So we're saying y is 3, so 3 equals, and we're saying x is 4, 4 minus 1, so 3 equals 3. That checks out. And then the other equation, again, we said x was equal to 4, so we have 4 and y is equal to 3, and that 7 equals 7, so that checks out. So solved for. Okay, always check your work. All right, so this is what they did in step 3. Substitute the x value into one of the original equations to solve for y. And I always suggest you substitute it into the equation that was solved for initially. Y was solved for. And we got y is equal to 3. So let's look at another example. So now ask the question, what equation and what variable would be easiest to solve for? So here I notice I have 2y plus x is equal to 4. And then the other equation I have 3x minus 4y is equal to 7. Well, I see maybe the easiest thing to do here is to solve for x. Okay, so in solving for x, I would subtract 2y from both sides, and I would get x equals 4 minus 2y. So x is solved for already. Okay, we're going to come back to that equation after we solve for what? Okay, so now what we're going to do, we're going to substitute 4 minus 2y, which is x, into the other equation. So we're going to take that x and substitute it into the other equation. Okay, so we're going to take, so this is the other equation. We're going to substitute x, which is 4 minus 2y, into the other equation. Okay, so we have 3x minus 4y is equal to 7. We substitute x, which is 4 minus 2y, minus 4y. All we did was just replace this x here. We just replaced that x with that there. And then we distribute our 3. 3 times 4 is 12. Oops. 3 times 4 is 12. And then 3 times negative 2y is negative 6. So we get 12 minus 6y minus 4y equals 7. We combine our like terms. So we get 12 minus 10y equals 7. Then we subtract 12 from both sides. We get negative y is equal to negative 5. And divided by negative 10, we get y is equal to 1/2. Y is equal to 1/2. Okay. So remember, x was the equation that we had solved for originally. That there. So we're going to take our solution for y and just substitute it back in to find out what x is now. We're going to substitute it there. All right, so let's do that. So here I have x equals 4 minus 2 times 1/2. 2 times 1/2, that's, and so I have x is equal to 4. 1/2 of 2 minus 2 is a minus 1. And so x is equal to 3. So my solution here, my solution is the coordinate point 3 and for x and 1/2 for y. Okay, so again, we should always verify that that was the correct solution here. All right, and so here I'm going to work with equation number 1. So we said y was 1/2. Well, let's see here. So I have 2, y was 1/2, and then we said x was 3, and then we're saying, hey, let's see here if that equals 4. Oops, that's 2 times 1/2 plus 3. Y is 1/2, and then x is 3 plus 3. Okay, so 1/2 of 2 is 1, and 1 plus 3, well, that equals 4. So 4 is equal to 4. So that checks out. And then we need to verify this here. So let's see here. So again, we have x is 3, so I have 3 times 3, because that was my solution, minus 4 times 1/2. And let's see here if that equals 7. Okay, again, we're checking the point that we're checking this coordinate point, x and y, into equation 2. Well, 3 times 3 is 9, and 1/2 of minus 4 is minus 2, and that does equal 7, so 7 equals 7. That checks out. Okay. Let's look at another example here. Another example. Again, here I have two equations. I have 5x plus 6y equals -9, and I have 2x minus 2 equals -y. Okay, looks like the easiest variable to solve for is y. It's kind of all by itself. The coefficient is -1. So what I can do, I'll just multiply that entire equation by -1. I'll multiply this by -1. And that will give me then, I guess we're looking at method 1 here, that will give me y equals -2x plus 2. The positive 2x becomes negative, the -2 becomes positive, and the -y becomes a positive y. So now I have y is equal to -2x plus 2. All right, so that's what y is. So then I'll take what y is, and I'll substitute it. I'll substitute for the y in the top equation. I want to substitute for that y there. Okay, so we have 5x. So we have 5x plus 6. Y we saw was -2x. -2x plus 2 equals -9. Okay. In here, they're presenting two methods. Here they isolated x, here I isolated y. I just think it was much easier to isolate y, because y was kind of almost by itself. It was almost 1, it was a -1. Now we continue. Okay, so we're still not done here. We have to evaluate that. All right, so we have 5x, we distribute the 6. 6 times a -2 gives me a -12x. And then here, I guess 6 times a -2 gives me -12x, and then the 6 times a +2 gives me 12. I combine my like terms, 5x minus 12x gives me -7x. And then I'll subtract 12 from both sides, I get -21. And then finally, divide both sides by -7, and we get x is equal to 3. X is equal to 3. Now remember, we initially, when we started this, we solved for y, which is here. We solved for y. So after we got this value for x, we're going to go back to that equation and plug it in and get y. Substitute and get y. So we have y equals -2. X is 3 plus 2, so we get -6 plus 2, and we get -4. All right, so my solution, and we found it, x is 3 and y is -4. So let's just verify that solution here. So again, I'm going to start with equation 1. let's see here. So x is 3 and y is negative 4. So I have 5 times 3 plus 6 times negative 4. And let's see here if that equals negative 9. So I have 15 minus 24 equals negative 9. And yes, negative 9 equals negative 9. So that checks out. And then I'll work with the other equation. So again, I have 2. X is 3 minus 2 and y. So we had a negative 4. Y was negative 4. So we're going to take the opposite of negative 4. So let's see, 2 times 3 is 6 minus 2. And a negative times a negative is a positive. 6 minus 2 is 4 equals 4. It checks out. Okay, so that's substitution in a nutshell. You solve for either x or y, whichever one is easiest to solve for. You take the value of x and y and you substitute it into the other equation, and then you find the value of that remaining variable. Then you take your solution and you go back to the equation that you solved x or y for, and then you find the other value. Okay, and they did that for us. Okay, next is good. So that's substitution. Elimination, I think, is a little easier. So we'll look at solving system of equations using elimination, also called the addition method. You can also solve system of equations with the elimination method. With elimination, you get rid of one of the variables by adding or subtracting. Okay, and I generally ignore subtracting. Basically, we always add. Okay, because after all, subtracting is just adding a negative number. Okay, so you may have to multiply one or both equations by a number to create variable terms that can be eliminated. The elimination method is sometimes called the addition method. Okay, and you'll see why. Important point. You want one of the variables to have the same coefficient but opposite in sign. To recall, what's a coefficient? It's always a number in front of the variable. So there 3 is a coefficient. Minus 2y. Negative 2 is a coefficient. Okay, the coefficient is always the number in front of the variable. You want them to be the same but opposite in sign. That way, if you have a 3x and a minus 3x, and when you add, well, you get 0. If you have a negative 2y and a positive 2y and you add, you get 0. So they'll be eliminated. So you want the coefficients to be the same but opposite in sign. So let's look at this. Example 2a. Use elimination to solve the system of equations. So I want you to notice here, which one we want to solve for, x or y? Well, come on, let's solve for y. The coefficients are the same but opposite in sign. So what we do, we just add. Well, 3x plus 4x is 7x. Okay, the 2y minus 2y, that goes to 0. And the 4 plus a negative 18 gives you negative 14. Divide both sides by 7, and you get x is equal to negative 2. X is equal to negative 2. Okay, so we solve for x, and now we have to solve for y. So we'll take x and then we'll substitute it into one of the original equations. Either one, doesn't matter. Okay, it doesn't really matter. Okay, I'd say choose the one that seems easiest. In this case, they both seem about the same. So here I have 3, but x is negative 2. And then plus 2y equals 4. And then I have negative 6 plus 2y equals 4. Add 6 to both sides, I get 2y is equal to 10. I get y is equal to 5. So my solution, the x that made the y is equals, well, x is negative 2 and y is 5. Oops, let me clear that up. And again, it's always a good idea to check your work. So let's do that. So I'm going to substitute negative 2 and 5 into both of these equations, see if I get a true statement. So I have 3 times negative 2 plus 2 times 5, and that's negative 6 plus 10, and that's 4, and that equals 4, so that checks out. And then the second equation, I have 4, x is negative 2, minus 2 times 5, so I get negative 8 minus 10, and that does equal negative 18, equals negative 18, so that checks out. Let's look at the next. Okay, so they did this one here, use elimination to solve this system of equations. So here I want you to notice that we have different coefficients for both the variables, different. Okay, but I need the coefficients to be the same in both equations but opposite in sign. Okay, so what we'll do in this case, and what they did, they multiply this first equation by a negative 2. That was a coefficient in that equation. And then they multiplied the bottom equation by the coefficient in the first equation, which was 3. Okay, so they multiplied the first equation by a positive 2 because that was a coefficient. That was the coefficient in the second equation. Okay, that was a coefficient in the second equation. And then they multiplied the bottom equation by the coefficient in the first equation, but it's opposite in sign. And so when we do that, we multiply the entire equation, the top equation, by 2. So 2 times 3x is 6x, and then 2 times 5y is 10y, and then 2 times negative 16 is negative 32. And then the bottom equation, negative 3 times 2x is negative 6x, negative 3 times 3y is negative 9y, and negative 3 times negative 9 gives you a positive 27. You add, you eliminate those, you get y is equal to negative 5. That's the first part of the solution. We found out what y was. Now again, we can go back to either one of these equations to solve for x. Choose the one that seems easiest. Okay, I'll just choose the second equation. It really doesn't matter. So here I have 2x plus 3. We know that y is negative 5. And that equals negative 9. Then we get 2x minus 15 equals negative 9. We add 15 to both sides, and we get 2x is equal to 6. Adding 15 to both sides, 15 minus 9 is 6, and we get x is equal to 3. So my solution here is 3 and minus 5. Okay, so... and I'm not going to check that, but it's always a good idea to do. So that was my solution, 3 and negative 5. Let's look at another. Use elimination, okay, to solve for that one there. All right, pause the video. I want you to just to work it out and see if what you get. Okay, they've already done it for x, so they notice here that the coefficients were the same but opposite in sign. So we just add negative 8x equals negative 6, and x is equal to 3/4. But pause the video and see what you get when you solve for y. You can substitute x into either equation, 1 or 2, doesn't matter. Okay, substitute x into either equation and then solve for y. Pause the video and try that. Okay, so they substituted into the first equation 4 times 3/4. So that's 4 over 1 times 3/4, and 4s they cancel. We have 3 plus 7y equals negative 25. We subtract 3 from both sides, we get 7y is equal to negative 8, and y is equal to negative 4. So negative 4. So our solution, x was 3/4 and y was negative 4. Okay, and So elimination is, I'd say, most kind of easy here. So let's look at this here. So these are the problems that we're going to be doing a lot of, okay? A veterinarian needs 60 pounds of dog food. That is 15% protein. So, and then he'll combine a beef mix that is 18% protein with a bacon mix. That is 9% protein. How many pounds of each does he need to make the 15% protein mixture? So he has beef and he has bacon. All right, so let's just take a look here. So he has beef and bacon. All right, so the beef, I'll just draw a patty of beef. And we know that's 18% protein. 18%. And then he has bacon, so maybe I'll make a bacon strip. And that is 9% protein. So 9%. All right. So here, when we solve this, what we want to do is we want to define some variables always. So we'll say, hey, let X represent the amount of beef mixed in the mixture, and Y represent the amount of bacon mixed in the mixture. So we have X and we have Y. Okay. Okay, we want to combine those two, and we want to get 15. So we want to get 15% of how many pounds? 15% of 60 pounds. Okay, notice if we do combine these two, 18% and 9%, they have to fall somewhere between 18 and 9. You certainly couldn't get 7% in the final mix. That would be impossible. And you certainly couldn't get 20% in the final mix. That would be impossible. It has to be somewhere between 18 and 9. Could be all of 18. You could use all of X. It could be 9. You could use all of Y. But it can't be outside those numbers. All right. So what do we know? So we know that the number of pounds of X and Y, that has to equal 60. So the number of pounds of X and Y equals 60. We define X is equal to the amount of beef mixed in the mixture. Okay, I would say let X equals amount of pounds of beef mix. I would present the pounds of beef mix, and then Y present the pounds of bacon mix. Okay, and so the total number of pounds in the end, the total number of pounds, it has to equal 60. Okay, but 18% of X, and then plus 9% of Y, well, that has to give us a final mixture of 15% of the total. Okay, 18% of X. So we have 0.18X plus 0.09Y equals 0.150. So what we have is that we have a system of equations here. We have a system of equations. We have two of them. We have X plus Y equals 60. And then we have 0.18X plus 0.09Y equals, if I take 15 or 0.15 times 60, 0.15 times 60, I get 9, which is the equations that we have here. Okay, so they gave us that. And then here we have an option. We can use substitution or we can use elimination, however you want to do it. Okay, so here they use substitution. They solve for Y. So they subtracted X. So they said Y is equal to 60 minus X. So that's what Y equals to. And then they took that 60 minus X and they substituted for that Y. So they had 0.18X plus 0.09 times the 60 minus X equals 9. Distribute the 0.09 to 60 and you get 5.4. Distribute the 0.09 to negative x and you get negative 0.09x. Combine your like terms, 0.18x minus 0.09x gives you 0.09x, and then subtract 5.4 from both sides and you get x is equal to 40. Well, it's easy to see here, if x is equal to 40, then y has to be 20. So 40 plus y equals 60, y equals 20. So they should have 40 pounds of beef mix, so 40 pounds. So 40 pounds of beef mix, because that's what x represents. And then they should have the 20 pounds of bacon mix. And that would give them a 15% protein mixture of 60 pounds. All right, and they did that. So here, I'll pause the video and see if you can do that one there. Read through that and then do that one. Okay, I hope you got the answer right. So, let's see here. If you keep working on it, so let's just do this and see what you came up with. We have coffee blend of Sumatra beans and Kona beans. So I'll just say X represent the, what do we have? Pounds of coffee represent pounds of coffee of Sumatra beans, and Y represents pounds of Kona beans. All right, so let's see here what we have. And we need a total of 50. We need how much of each type of coffee is in 50 pounds of the blend. So we have X plus Y equals 50. Sumatra beans cost $5 a pound, so 5 times X number of pounds times 5 would give us the total cost for Sumatra, and then 13 the cost for Kona beans. It's $13 per pound, so 13 times the number of pounds of Kona beans. Okay, and so the total cost there, if the blend costs $10 per pound, okay, $10 per pound, then how much of each type of coffee is in 50 pounds of the blend? It costs $10 per pound. So this is the total cost here. Oops. Yeah,